Hello, my name is Abdulqader.A. Today we'll be discussing this problem, which is a full control problem, and trying to solve it using an SFC language, which is a sequential function chart. Okay, so what is the problem of the full control? You can read the text over here, but I'll be summarizing it in my next letter. So you have a bottle or a cube or something that needs to be full in water, and this water will be had to be heated until it reaches a temperature. So this pumping here will be controlling it if the level is below that, and if the heating element and while pumping, the heating element will be heating the water until it reaches a temperature. There's also here a sensor of the temperature. So if it reaches this temperature, it will be turned off. If it not reaches, it will be remain heating. So we can start implementing it. I'll use my Automation Studio 3.0.5, my demo version of it. If you have the full version, it's okay, or any version that uses SFC. So we start by taking that library over here and doing that SFC. So we need a step. A first step is my initial step, so we'll call it an initial step, and use a transition which is equal to 1, which is conditionless. It will just take us to the next level. It's not doing anything right here. So the process is about two things. Okay, the first process is heating, and the second process is pumping. So we need two steps over here, and be working together mean it they are in parallel. Okay, so we can link them. We can connect this over here directly and link this to that and get that over here. Okay, so we can call this the heating process and call this the pumping process. Okay, and we're gonna need here a transition which is equal to 1 conditionless like this, and another transition for the other one which is also equal 1, which is conditionless. Okay, now we start our control by taking the step. This step will be heating our heater on. Okay, this will be connected to an output, which is an action, so we need the action here. Okay, and it will be y1. Be sure you double click on it so it can be reached here or it will not be linked. Okay, and we're gonna need another action, another step for this, that will be start pumping. Pumper starts. Okay, and we're gonna need an action here which is linked to y2. Okay, this is y1, this is y2. Okay, it will be start heating until what? Until it's too hot. Until it's too hot, this means another transition. Another transition will be linked to x1, which is a sensor that we have. Okay, x1. And this will be start pumping until it reaches the next level, the level that we want, that which is x2. Okay, so let's leave this. Let's leave the pumping operation, go to the heating operation, and finish it. Okay, so the heating process will be stopped. So we need a stopper. We need a step here, which will be stop the heater. Okay, and it will be linked in an action which is not y1. Okay, as you can see, I missed that double click on y1, so you need to double check on it. Okay, so it will be not y1 and will stop working. When it will be re-begin again, if the lever temperature is decreased. So we need another transition here, which is not x1. You can call it too cold. Okay, which is the opposite of this, which is this. You can call it too hot. Okay, you're gonna be link this so it can be start the process again from here. Okay, so this is for the heating process. Now for the pumping process, you're gonna need the step here. Okay, let's review what we do. So the pumping start will begin until x2 happens, and with x2 which reaches the level. As the problem says, when you reach the level, you need to wait 5 seconds. So 7 is not here. You may think in the first that this is will be a not y2. Okay, you may think this, but that's wrong. You need to wait 5 seconds. Because at the point the water when it's rising up, it's not rising in a specific way. It's just vibrating. So a lot of water may reach the level, and while the actual water is not reaching. So instead of using a more complex sensors like buffers or something, you just need to wait 5 seconds, which is the transition here. Okay, which will be x2. Sorry, x2. It will be a timer. Okay, the timer will be x7. X7 means that this 7 is 5 and wait it until n second. N second we need it 5 seconds. So 5 seconds. Okay, and now we're gonna go to the next step, which is stop pumping. Okay, and not y2. Okay, you need to connect it until it's black or it's not working. Okay, so when this happens, what you really need to do here is the next transition. So it will be stop pumping until what? Stop pumping until the level is down again. So you're gonna need a not x2. Okay, which is the opposite of fair. Okay, I'm gonna link it again to 5. Okay, so I think this is all for the controlling program, but we're gonna need to check our words, so we're gonna need some hardware circuit. So let's go to the PLC ladder and go to the rank input. We're gonna need 2 input. The first one is called x1, which is the sensor of the heating, and the second input will be x2, which will be the sensor of the pumping, and 2 outputs which are y1. Okay, y1, and another output which is y2. Okay, this is it. Okay, let's move this a little bit so it can fit the screen. I messed this up. Okay, just take this better here, take this better here. Okay, don't care about this. Okay, so now we're gonna use our y1 to indicate it. We're gonna need a component, which is go to the library again, workshop, go to the electrical control US, and with output component, we're gonna use anything of that will be good, but I'm gonna use the indicator light because that's so easy and obvious. Okay, I'm gonna get in the red. I'm gonna use this indicator light here and indicate it in the blue. Okay, now I'm gonna need some neutral line so it can complete the circuit. Not this, power source neutral, right? Okay, so if you're gonna need to connect it, you go to the electrical control US from the lines here, electrical wire, and you can connect it in parallel. Okay, now this is all for the okay, never mind. It's all for the y1 and y2. Now for the x1 and x2, we're gonna need switches, which are Okay, wait a second. Switches here, right here. Toggle switch. Let's call this an X1, and another toggle switch with it, which is okay, which is X2. Okay, and now we're gonna connect it to a power source, which is a line, which is go another line to this, not the line. Power sources, right? Okay, electrical wire. So we're gonna link this, we're gonna connect this and connect this, and okay, this is the end of the process. Let's check our work. So as you can see, this is working because X1 is not working, and this is working because X2 is not working, which is not hot and not reach the level. If it's too hot, you can see it comes from 4 to 6 and stop the operation. If it's too cold, so means not X1, it will be restarted again, and can be see like it's like a loop, you know. For this, if you press on it, you can see that it comes here and wait for a second and come for here. But we have, it seems like we have a problem. If you can see it, okay, we can see it here. It has to have not Y2 only after 5 seconds, like you now see, you know. Okay, this is working and this is not. So we can implement this. We can solve this question. It's not that hard. We need here an action here, which is will be linked to Y2. Okay, which is like this. So the operation must now work. Okay, this work, not work, not work, work, and here, okay, working. And after 5 seconds, it will come here and turn off. So this is it for this problem. I hope you liked the video, and thank you.